Hello, welcome to Beginners Python and Machine Learning. My name is Tim Cummings. We're a meetup group that helps people get into Python and just go through some of the programming techniques. And we do live sessions so that you can ask questions online while the session's going and get live answers. So let me know if the volume's okay on this computer. I've just moving to a Windows 11 computer for this session, so it's the first time I broadcast from it. I'll be looking in YouTube chat for any questions that you might have, and I'll also be looking in Slack as instructions on how to join the Slack group in the description below this video, but you can also just send your comments in through YouTube. Learning to Code is the channel in Beginners Python if you want to ask questions. So today we're going to be looking at how to create spreadsheets in Python using the third-party library xlsxwriter. So this will create spreadsheets that are in the Excel format. Of course, that can be opened with other spreadsheet programs as well. We're going to be doing it all in Google Colab, and I've prepared a notebook for you. And if you look below this video, you'll see a link to colab.research.google.com, and the link's also on Meetup, which is where I'm getting it from. So if you click on that link, it'll open up the notebook for you. So just open it in a new window so you can have the video and the notebook side by side as we go through. Now the first thing to do, this is my copy, and see it says changes will not be saved. That's because you don't have permission to save this notebook to my area, but you can copy it to your own Google Drive, and then you'll be able to make changes as well as running it, and that's what's going to be fun. Now, spreadsheets are really useful. Creating spreadsheets in Python is really useful. If you've got lots of data and you need to give it to users in a form that they can do something with it, take it away and do something with it, then putting it in a spreadsheet is a really good way of doing it, and you can format it nicely as well, so it looks very professional. So what we're going to do today, we're going to collect some data and we're going to put it into a Excel spreadsheet, and the data we're going to collect is a catalogue of all the online courses that I've done for this meetup group. And so it'll list the names of the sessions, it'll give you the YouTube links and also the links to any files and meetup events and stuff that are relevant. So let's start using. Now we're in our Colab notebook, which is a Jupyter notebook. It should say copy of and the meetup name. And up in the top right hand corner we'll click on connect, and that will tell Google to start up a new virtual private server for us so that it can run, and it'll allocate us some RAM and some disk space to do this session. Now these notebooks, there's just a series of cells. You can see a cell here with some text in it, formatted text, and some links to different parts of it, and then you've got these other cells with a grey background, which are the code. And the code is normally Python, although the very first line of code, you can see it's prefixed with an exclamation mark, which means I want to jump down to the command line and run this from the command line on this computer that Google have given us, and it's going to run the git command so we can grab our data from GitHub. Now to run a cell, you click on the play button here, or if you see if I hover over that, it also says Control Enter is a way of running it if you want to use the keyboard instead. So I'm going to run it, and it's going to jump down to the command line. It's going to clone into a folder called BPAML sessions, which is Beginners Python and Machine Learning sessions. and it's going to get all our sessions that we've put up there. And that's a good repository if you want to go back through any of the old sessions. In fact, you can use the output from this session tonight to keep a directory of all the sessions, or the ones that I've done anyway. If you look down this left hand side, there's a few icons. One's for folders and files, and that'll show the folders in the directory that we've just been in, and you can see it's created this one, BPAML sessions. In there we've got the ones we did at River City Labs, at Red Hat, at State Library of Queensland, the TC Byrne building, and the ones we're doing now, which are all in the online folder. Okay, and you'll see these ones have all got a meetup number and then a name. So all the ones with Tim in them, they're the ones that I've created. So they're the ones we're going to be doing a directory of tonight. Okay, so back to Python. Now this is really a case study, so it's not really showing you any one piece of how to use Python. It's just grabbing different bits of Python that we need for different things. So you'll find that I'll be jumping all over the place in the sort of what we're going to be doing. Now when you want to use a library in Python that's not one of the built-in libraries, then you have to import it. So we're going to import the path library. It's one of the standard libraries, so you don't have to install it, but you do have to import it if you want to use it. And we're going to use pathlib from that. And in pathlib there's a class called path, and it's going to look in our BPAML sessions folder, and inside that there's a folder called online, and it's we're going to store this path into online directory. Now we want the scripts that end in .py and the markdown files that end in .md, and actually for this one we're going to also grab the Jupyter notebooks, because sometimes I put a Jupyter notebook up, and so this is an addition to the last time I've done this. And they end in .ipynb, and we want the ones written by me. So we're going to use this method on our online directory object that we've created, that finds all the ones with a Tim in them and that end in .py, all the ones with a Tim in them that end in md, and all the ones with a Tim in them that end in .ipynb. I will store these in a list, which I've called LST scripts, and then we'll just do a loop through those scripts. They're all the names of scripts. We'll just go a loop through those scripts and print the name of each one out, and then we'll have a look at what the data type is. So let's run that. So you can see they're all in a jumbled order. It's given the names, gives us the full path to get there, well, relative to where we are, because we called them up in a relative fashion. And if we look right at the bottom to say what type each one of these objects is that we've just printed out, each one is of type POSIX path, and it's in part of pathlib, but we can get the names from it. Okay, so the first thing we're going to do is take our list and sort it. So let's run the sort method on list, and now up here I did print command or the print function to display the names of each of the files. In notebooks, if you're getting lazy, you don't even have to put in the print function. You can just, if the last line returns something, Jupyter Notebooks will just display it. Can display it in a slightly different way, but in this case, this is what it looks like. It's telling us that each one's a POSIX path with that file name. And now they're all sorted in order that they've been presented. So the last one should be today's session, which is 218, creating spreadsheets. And it's a Python file. Okay, now we want to use this third-party library, xlsxwriter, which I find is the best. There's a couple of them. PyXL is another one, but xlsxwriter is the one that I find is the most flexible and gives me the most control over the spreadsheets that I create. Unfortunately, it doesn't come with Google Colab or even Anaconda, so you need to install it. And to install in Python, the best thing to do is create a virtual environment and install it using pip install inside that activated virtual environment. Now we're using a Google Colab, which its virtual environment is basically the entire VPS, the server, so we can just install straight there. So we can just type pip install xlsxwriter, and I'm just putting an exclamation mark at the front because we're running it from the command line. And so let's run that and see if it works. And it does. So it goes off to Pippy, finds the latest package in xlsxwriter, downloads it. It would also, if xlsxwriter depended on anything that we didn't have installed, it would grab them as well and install them, and now we can run xlsxwriter. And you'll notice before we did that, I was getting an error message here when I was trying to import xlsxwriter, but that error message has gone away. It's no longer underlined because it's now installed. So let's import it, and we'll create a workbook. So to do that, we use this class here, workbook, which has got a capital W at the front, and we put in the name of the file that we want to create, and we give it a reference in this with command. So the reason you use with is that when you're opening a resource like a file, once you get out of the with code block, it will automatically close it for you. So it's a really good way of opening files using with, because it will you don't accidentally leave files open, which is a bit of a hazard on computers. So do it this way and you never have to worry about closing it. Then anything that's indented is part of the code block, and if when it gets to the end of that script, which is in this cell, or it comes to some code that's no longer indented, that'll be end the with code block and it will close the file. So we're going to create a workbook. We're going to add a worksheet to the workbook, and we're going to call it scripts, and then we're going to loop through all the script names that we have in our list of scripts, and we're going to use this write method to put it in a row, column, and what the name is. Now we have to convert it to a string, because remember it was a POSIX file, each one of those scripts, and so we just convert it to a string by calling the string function on that path lib POSIX path, and that will just give us the name. So let's run that and see what comes out. This is actually going to be interesting. I may not have installed. Alright, so if we look over here, there is our file that we've just created. So we can download that and have a look. And it's opened it for us. Accept. Let's go accept. Alright, well, that's why we're getting all of this stuff. Don't send optional data. Alright, and yes, I haven't activated this, but anyway, well, we shouldn't need to activate it for this session. So you can see down the bottom here we've got one worksheet called scripts, and then on each of these rows we've got the name. If I can double click on that, we'll just make the column wider, and so everything's in column 1, and it's just the name of each of the scripts. So that's creating a spreadsheet. It was pretty simple, and now we're just going to do some more things to make it a bit prettier. so that's that one. Now in the spreadsheet we had the full path name, but maybe we want to split up the different parts of it, and so I've just run some print functions here that look at different parts of the script path lib, pure path, and what we can extract from it. So we can extract a name, the stem, suffix, parent, and a list of parents. So let's run it and see what just on the first item in the list. So remember, this is our first, that's just converted to a string, and it's got the full relative path from what we called up. Now we could just pull up the file name, and that doesn't have the directories, just the file name, including the .py on the end. We can look at the stem, and so that's everything before the .py, or we can look at the suffix, which is everything after the dot, including the dot, so that's .py. If we look at the parent, it actually returns an object, not a string, of type POSIX path, and that's the name, the full path to get to that file, or we could split them up into individual directories so that we can refer to each one individually, and in which case to do that we use parents, and it gives us a list. Well, we've converted it to a list, and the first one is the current one that it's in. The second one is the path to the folder that folder was in, and the third one in this case is the top folder containing all the others. So they're the parents for each folder that we're in. So I've set you a task here, so you can pause the video and have a go at it, just with the information that we've created so far. And then we'll do a solution. So we want to store index I in column A and the script name without the suffix in column B. Okay, so let's do pretty similar to what we had. We'll create, I didn't want to do that, we'll close that. We'll create a new file this time. We'll call it 1 for task 1. We're going to add the worksheet scripts as we did before, and we'll go through we'll enumerate each of these, which means give us the counter and the script itself, and we'll store them. So we're going to store the script name in the second column, column B, which is uses integer 1 because the column A is integer 0. We don't need to convert to a string because we're going to use a function that gives the script name without the suffix, which was stem. So we'll call script.stem. And the other thing we're going to do is we're going to store the number sheet.write, and we'll store that in the same row, so it's row A, I, the first column, which is column 0, and we're going to put a number in there, so it'll just be I. So let's run that and look over on the left, and eventually, actually we can refresh, and there is number 1 come up, and we can download that. And let's open that one. So there we go. We've got column B has got all the names without the .py and without the folders, and column A has got just our counter number. So, and we can no, we can't actually do anything, so that's all right. We're just looking. So I hope you managed to be able to do that. let's have a look at the solution that's provided, which did a few extra things. So this solution shows different ways of doing what we've just done. It's going to add an extra row in at the beginning, and it's going to put some titles on the columns. It's going to increase the width of column B to 50 whatever units Excel uses, and it's going to now, because we've got titles, we have to move the row down one for each, and it's going to put the number and the script.stem. So that bit we got right. So let's run that. That will runs pretty quickly. If I refresh that, it's not going to change anything because the name's the same. But let's download this file, and we can see now we've got the title row and then the names as before. So remember, that was using A1 B1 rather than having to work it out in numbers, which was 0 0 and row 0 column 1. Task 2, use the A1 type references to write script stems. Okay, and I've given you a link here of how to work with cell notation. So let's do that. So we're going to do the same thing. We'll call it I'll call it 2A, so then we know that it's different to the one that we're going to use in the real solution later. And we want to use A1 type references to write script styles. So this one here is going to be column A and row I+1. So let's put them into a string. We'll use an F string, and it's going to be column A, so I'll just hard code the A in there, and then the I+1 will use the F string feature of evaluating an expression and make that, so that'll be but in fact we don't want I+1, we want I+2 here to get that to work, because when we use rows and columns it's 0 indexed, but when we use letters and numbers it's 1 indexed. And similarly for this we're going to do B I+2. Okay, there's our file, and let's have a look at it. We'll also check this column width. I didn't remember to check that last time. So yeah, there's the column width is even wider, so that's good, and our names and numbers went into the right rows and columns, so that's all good. So let's look at the solution. And the solution, I've shown a few extra formats that we can do. So for example, when we write in meetup, the word meetup in the cell A1, we can format that center, which is using this format up here that we've created called align center. So the way you work with formats is you create a format, you add the format to the workbook, and then whenever you're writing a cell, you can refer to that format. And it's just a memory efficiency thing that Excel does when it's storing formats. It just stores the format in one place, and then a lot of cells just refer to that format. The other thing, then when we're writing the meetup number in the first column, we can use that same format, so that's centered as well. And rather than just using the enumerate I, we're going to calculate the meetup number by extracting that from the string, and we're just going to grab from characters 6 to 9 in the name, and that's where the meetup number is stored. So this will put the meetup number rather than just a counter, and it's going to number 2. So let's run that and have a look how that looks. There we go, that column's now aligned, and we've got meetup number 52 is this script name, meetup number 53, so there's 52 is when we started doing them online, well, when I started doing online, and there they all are. And then we sum this, but Excel's decided not to run formulae for me because I haven't activated it. I wonder if I've got LibreOffice on here. No. All right, quit out of this. I'll start the download now, just in case we need it for some reason. Okay. All right, get rid of that. All right, so task 3, we're going to do a similar thing. We're going to format the first row in bold using this sort of formatting. So we're going to use setting bold and using the Python value true. So let's copy and paste so that I don't have to do a lot of typing. We'll call it 3A. We'll create a new format. Called bold, and it'll be bold equals not a string this time, it's a Python value true, a boolean, and format the first row in bold using bold true. Okay, so these are the first row, so we'll call it format bold. Let's run that. And refresh. And there we go, our first row is now in bold, but you can see we've lost our centering on the first, on A1. So what can we do about that? We'd need to have both align center and bold for that to work. So let's have a look at the solution, see how that's been done. So these formats, they're just dictionaries. So we can put several things in the one dictionary, several formats. So I could have align center and bold true. So what we're going to do, we're creating a dictionary for everything in column A, and we can create another dictionary for everything in column B. And then, sorry, not column B, in row 1. And then for cell A1, we need to merge the column A and the row 1 formats into a single dictionary. So I thought I'll just show you how to merge two dictionaries, but we still want to keep the originals. And so I've called all these formats DCF, dictionary format, just so I know what it is later when I'm looking at it. Now these days in Python, we can use the pipe symbol to merge two dictionaries and produce a new dictionary, which we will call the format for A1. Now if you're using an older version of Python, so this was 3.9 or later, can use this way of doing it. If you're using anything before Python 3.5, you'd have to create the new dictionary and then update it from your column A values and then update it from the row 1 values. So that's one way of creating it. Between Python 3.5 and 3.8, they had this sort of notation, which is pretty wacky. So not really that clear, but it uses these unpacking operator, ** dictionary, and that will unpack it to a bunch of keys and values, and then it's going to unpack this one to a bunch of keys and values, and then put all of that into this new dictionary. And now Python 3.9, this is a lot easier to understand. Just use the pipe symbol. So we've created those, we've merged them, and that's created 3 dictionaries. Now we create 3 formats that all get added to our workbook, and then we can use those formats in our write commands. And so in cell A1 we use format A1, for everything else in row 1 we use format row 1, and for everything else in column A we use format column A, including the total at the end. So let's run that, and that's creating number 3, which is there. We can see that indeed column A is row 1 is centered and bold, and in fact the rest of the things in the rest of the rows in column A have now got padded zeros on our meetup numbers. Let's just grab this. It's still coming down. 2 minutes. Okay. So to see how to do the formula, we just use the write command again, and as before we just specified where we wanted to put it, and then the string that we put in was a formula starting with an equals sign, and we're summing from A2 up to a row number, and xlsxwriter will automatically work out that it's a formula because it's starting with equals, and it will put it in as a formula rather than just as a string. Okay, now we want some more information about to list in our spreadsheet. So we're going to open up each of these files that we've downloaded from GitHub and find out the URLs where you can go to for YouTube or for Colab or for Meetup. So we have to open each file one at a time. Let's have a look at, we'll open up the first one, and we'll read the lines in that and store it in a list called lines, and then for the first 10 lines we'll just print them out. So this is what the first 10 lines looks like in that file. Now the other thing we could do is go to the source, which is github.com, and we'll look at my repositories, and there's BPAML sessions, and in online we'll look at the first one of these, and you can see that's the first 10 lines or so of the file. And we're looking at these lines here like YouTube, Colab, GitHub and Meetup, and we want to grab these URLs. Alright, I can just look at the raw value of this file. That's what it looks like. Okay. So, task 4. Open the 20-second file and read the first 10 lines. Well, that's a pretty easy task. I think the only trick to this is that to get the 20-second file, you want to use index 21 because it starts at 0. So this is Meetup 87, and it does a similar thing. And there's a solution. Oh, and f.read.splitlines. So this is using the different way of calling the lines out of a file as using f.readlines. So remember, opens a file, f, and we've by default it opens it as an ASCII file or a text file, and stores a reference to it in f, and then f we can say f.readlines, and that will give us all the lines, but it will keep us the line feeds at the end, which is these also represented by \n, and so we put a dot strip on that so that it doesn't print spare lines. Now if I didn't have that dot strip there, you'll see it's double spaced because it's printing a spare line for each one. Okay, so we want to find the title in the file. So the first line to contain the word meetup or meetup. So I've got different capitalizations, and we're going to use regular expressions to do this. And if you want some more information on regular expressions, go look at Meetup 074. But we can basically, when you're doing regular expressions, so you use the RE for regular expression libraries, we compile a pattern, and the pattern, we create a string, and it's best to use raw strings so that the special characters that Python uses for telling us things about the characters in the string are the same special characters that regular expressions use, and so you're having to use double backslash represent a backslash, and then that backslash is used in regular expressions. It gets very confusing. So just use an R out the front of the string, and then you can use it. We haven't got any backslashes in this, so it's not really a problem. And then when we compile it, we can say we want to ignore the case. So we're looking for meetup. It can be uppercase, lowercase, any combination of cases. So we're going to loop through all our script names. We're going to open up the file and read it using read lines. Then we're going to, and that's if it's a Python file or a Markdown file. And this is an extra bonus for this tonight's session, is if it's an IPYNB file, then that's actually a JSON file. And so we're going to use the JSON library to load it in. So let's have a look at what a JSON file looks like. We'll go back to online, and we'll find, where's the first one that I do? I did one recently. So this is Google Colab's gone and very nicely formatted our Jupyter notebook for us. But if we click on raw, it'll show us what's behind the file, and you can see it's JSON. So we've got curly braces. Inside the curly braces, there's a attribute called, or a key called cells, which has got a list, you see, or in JSON terminology, an array of objects, and each object looks like that. In each case, one of them is, the cell type is markdown, and the source gives us a list of strings that are in that source. So we can read that list of strings using the JSON library. So we load the whole file using JSON into a dictionary called notebook, and then we look in the first key cells, the first cell in that list of cells, and look at the attribute source, and that will give us the lines here, or if we read the file we'll get the lines there. So these two will give us the same thing, this one for notebooks, this one for Python scripts and markdown files. And then we're going to use our regular expression to match in that line. So we look for a match, so that'll be false, 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 until it finds the one with meetup in it, and that will append it to a list called meetup. So what are we doing this? We're doing this for all scripts, but we're just finding the first one for each file. Once we find one, we break out of that loop, and so we only get one from a file, and then they'll all be stored in this list meetup, and we'll print that list out. And there they are. These are all the meetup names. So that's what we're looking for. So we've got the meetup name, the number, and the date, and a description of what that's going to be about. That's pretty useful. So let's grab these dates. So the dates are going to be 2 digits for the day number, 3 characters for the month, and then 4 characters for the year. Oh, and sometimes, because I'm not very consistent, I think on the early ones, here we go, here's one, I put 19th, I put a TH in there after 19. So we've got to make sure we catch that as well. So we can parse, so for example, if I wanted to parse that time, I would use this format using the datetime library. And if I wanted to parse this format, then I would use %d for the number and then the th there. So that's one way to do it. Let's run it. There we go. And they both produce the same date. But we could also do the same using regular expressions. They're very powerful, but a bit complicated to go into detail. But we're basically saying, I want 2 numbers. I want digits, and there can be 1 or 2 of them. Then I'll optionally have 2 characters. So the question mark says optionally, and then a space. So that space is important. And then 3 characters for the month, 3 or 4. So sometimes I might have put June and July in there rather than just JUN. Then another space, and then 4 digits. So that's my regular expression, and this is how I'm using it. I won't go into details, but let's check the dates that we get out of that. So I printed the date first, and then the title, so we can see if it's getting it right. So 8th of March 2022 gets translated into a date where that's the year, month, day. And so that looks like it's working. Let's see if we can find one. Oh, so I've even got some, I've put a day in there as well. So where did I have my 19th? Here we go. Here's the 19th of January, and that also was translated correctly. Okay, using regular expressions, find the YouTube URL for each meetup. Okay, so let's grab some code that we did before. I don't need to import. Once I've imported, they stay imported for the rest of the script. All right, now I want to look for YouTube, and so a bunch of characters and then the word YouTube. Not worried about case, and let's just leave that the same. And there we go, it's extracted the YouTube line with the URL from each of those lines. Now it's Google Colab's actually converted these into URLs I can click on. That's nothing that I've done. Okay, so here's a problem. It's found the word YouTube in a line in the file that was before it actually said YouTube. So let's have a look at the solution. The solution's been a bit more detailed. It's created a pattern for Python files and a pattern for Markdown files. So in the Markdown files, it will be looking for Meetup. Why am I looking for Meetup? And in the other files, in the Python files, it'll be looking for just it knows that the title is going to be in the first row of the Python file after a and it's going to be in a doc string, so the doc string could start with an F or an R or both F and R, and it could have quotes in it. Then it's going to look for here it's going to look for GitHub rather than YouTube, but we could have looked for YouTube, and it's going to use these regular expressions, and we are running short on time, so I don't think I'll go into too much detail on how the regular expression works, but it's looking for the title that we've given it, it's escaping it so it doesn't become a regular expression itself, and then after that it's looking for a colon, or optional number of characters, a colon, optional number of spaces, and it's looking for HTTP, which may start a URL. It could be HTTPS as well, and it's going to create that for each of the titles that we've put in a list of titles. So we put this all in a function so we can use it again later, and we're letting it ask for a whole bunch of titles, not just one. But in this case we're going to only ask for one, which is the GitHub one. So let's have a look at that. It's creating these dictionaries, it's grabbing the doc string and the GitHub link and the URL for that. So that if you tried doing that code without using regular expressions, you'd have a lot more code. So even though regular expressions are very terse and difficult to read, if you put in a good comment saying what you're trying to do, and then put the regular expression in, it can save you a lot of coding. All right, so let's do the same thing, and this time find all four. So you can see this one just gave me the GitHub links, but now let's find all four links. So we've got Colab, YouTube, Meetup, and GitHub. So create a spreadsheet with the columns Meetup, script and sheet scripts, and these columns in a sheet called links, and yeah, okay, so we could have a go at that. So let's grab one of our code sessions, and I can call this function because it's previously been defined. That's great. When we're creating a creating a spreadsheet. Right, back up here. All right, so task 6, so we'll call it 6A. A sheet called scripts, and another one called links. So I'll just call it worksheet links. So we're going to, I'll get rid of some of this, we don't need this anymore. So in our list of scripts, we're going to get the dictionary. I'll just call it D equals parse pylines. In script, and we're going to look for sheet scripts. So in fact, meetup and script is already in sheet scripts, so this is all going into sheet links. So let's just put it, we'll do another well, in fact, we can do it here. It might just be a bit confusing. So let's copy this, and we'll do all one worksheet first, and then we'll do the other one. And we want meetup, date, YouTube, meetup. Okay. So A row is going to be the meetup, which we've already got. B is going to be the date. So we got, is the date. How do we get the dates? I think we had a function for that. Date from meetup. Okay, so we just provide the title. List and list meetup. Well, I might skip the date for now because it's just running a bit short on time, but it's in the solution, so we can look at how to do that. So we'll do, and we'll just do meetup and YouTube. So I've got the meetup, that's right, we'll put that in the first column, and in the second column we'll do, we've got to call this properly, path script, and we'll just grab the YouTube one. And that's going to go in the links. Worksheet. So you can see now this first worksheet's the same, and then we've got links, and it's got a meetup number and a YouTube link, and it's automatically converted them to clickable URLs, which is not something I did, so that must be Excel just working it out. Okay. I'll just quickly install this so you can see the sum working. So let's have a look at the solution. So the solution, we've created a function URL last, so that it will find the last segment of the URL. And that's just to make our URLs a bit shorter, so we don't have all the HTTPS and the name, the domain name. And we're going to, we've done all the formats as we did before. We did the first sheet, and we're going to let's see, so we're setting a few column widths here, so the links, because the links can be quite long, and we're even doing some freeze panes if that's something you'd like to do in your spreadsheet. And we're going to, so that's the first sheet, and then once we've done that, worksheet.write, we're putting all of this into one worksheet, it looks like. Oh, so I did all one worksheet in here for scripts, and then I just reused the same variable name for the links one. So all of this is in links. And I've also got the dates, so we've got date from Meetup, it gets it from the doc string, and when it writes it, we just provide a date, and xlsxwriter works out to do that in the date format. So let's run that and have a look at what gets created. So a scripts worksheet, a links worksheet, and you can see the columns that we've created. You can see these are date, they're actual dates and just been formatted. So the date's formatted, the date's stored like in numbers, but when it gets displayed, it's showing with the letters for the month name, because that's the format we've put on it. Each of these URLs, you can see if I hover over it, it shows the full YouTube URL, but to make the URL shorter for display here, I've just showing the last bit of the link, so we can see that all the links are different. And GitHub, I've even on GitHub I don't always put the file, but I've put it here. Oh, and the other thing I was going to check was that the total is working. So there's the total, and in LibreOffice there's a setting in settings that you have to recalculate, but if I press F9 key, it'll recalculate for me, and that gives me 15170. But if you go into Tools Settings, you'll see there's a spot that if you want to open an Excel file, you want that to be automatically recalculated, which is then got the same behavior as Excel. Okay. Oh, and that's the end. So there was something else interesting that we did here. Oh yeah, we created a URL. So you see, normally I've just been using write. There's actually a function here called write URL, and when you do that, you can actually say what the URL is that you want to write in and what the string is that is going to be the text that is seen when someone's looking at the URL, and they have to hover over it to see the full URL. So that's one interesting thing that was happening. Another interesting thing is sometimes I was using source for the source code, and sometimes I was using GitHub as the key. So I've done a search for both of those and just grabbed the first one that comes back when I'm populating that column. Well, I hope you found that interesting. Really, really useful. I use making spreadsheets quite a lot, especially if you're working in data science. That's a good thing to do, and you know, you'll find it useful to be able to produce these spreadsheets. They work in LibreOffice, they work in Excel. Didn't get any questions, but I hope you found it interesting, and yeah, until next time. I think that my next one's going to be in 3 weeks' time. I'll do an absolute beginners one on the first week of August, and so I hope to see you then. Arun will possibly do another. He did a machine learning one last week, and that was quite popular, so hopefully he'll do some more at the end of this month. I'll see you later.